Okay, this is 6.7. We're going to solving radical equations and inequalities. This is going to be a pretty short chapter. So most of this should be review except for the inequality part, somewhat. So our objectives are to solve equations with radicals and inequalities with radicals. And we have only 3 vocabulary words: radical equations, extraneous solutions, and radical inequalities. So let's get right into 6.7. What is a radical equation? Well, it's just an equation. It includes a radical expression, which means you have a variable under a radical sign. We've already learned that. So we can solve them by raising each side of the equation to a power. All right? So in this key concept, that is really important. This is the steps for solving radical equations. Remember, equations is an equal sign. So we have to isolate the radical sign by itself to one side. Then we raise each side to a power. If it's a square root, to the square. If it's a third root, to the third power. If it's a fourth root, remember, the root is the index. Then we just use algebra and we solve. Once we get a solution, we must check our solution back into the original equation. The reason why we do that is because it hits our next vocabulary word, which is extraneous solutions. We've heard about extraneous solutions before. So when we're solving them, we can get a solution, but we put it back in, it does not give us a true statement. We call that an extraneous solution. And it is not a solution of the function. It's an extraneous solution, which is kind of like not a real solution. So let's look at example 1. They want us to solve the square root of x plus 2 plus 4 equals 7. Okay, so how do we do that? So let's look at it. So we have the square root of x plus 2 plus 4 equals 7. So the first thing we're going to do is we're going to isolate the radical. So I'm just going to use algebra, minus 4 from both sides. And we get the square root of x plus 2 equals 3. So now that it's isolated, it's not times anything on the outside or plus or minus anything. So now, because this index is implied 2, we're going to square both sides. When we square this, remember, this becomes just like when we complete the square x plus 2 equals 3 squared is 9. We minus 2, and we get x equals 7. But we need to make sure it's not an extraneous solution. So we put it back into the function, the original function here. So I'm going to do 7 plus 2 plus 4. Okay, that's 9. The square root of 9 is 3 plus 4 equals 7. And 7 does equal 7. So we have a good solution. Let's look at example 2. Slightly different. So we have the square, 1b. X minus 12 equal 2 minus the square root of x. Well, we have 2 radical terms, don't we? So as long as they're on separate sides of the equation, we're good. So it checks off the box, is it isolated? Well, because we're going to always look at the one on the left side that's by itself. Because this could be an index of 2, and this could be an index of 3. We always want to go by the first one that's isolated, because this side is not isolated. So we have to isolate one of them. Because we could have 2, 3, 4. We have to start with isolating one, square it, cube it, whatever its function is, then simplify, and then isolate another one and another one until you've gotten rid of all your radical signs. So because it's implied 2, we're going to square both sides. This becomes x minus 2. So remember, we have a binomial here, so we have to FOIL this. This implies 2 minus square root of x times 2 minus square root of x. All right, so when we FOIL this, we get 4 minus 2 square root of x plus x. All right, so now we are going to continue. Whoopsie. All right, so here we are here. So we get this right here. And we're going to simplify. All right, so, oops. If you notice here, if I minus x from both sides, this goes away, right? And then I'll minus 4 from both sides, and I get minus 6 equal minus 2 square root of x, and I think, or 4, sorry. Yeah, 2. Oh, this is 12. I wrote the problem down wrong. That's where the problem lies. Okay, so this equals minus 16 equal, and then I didn't, 4. This is a 4 because I forgot about the 2. So this actually I folded wrong because I did it in my head. So this becomes minus 16 equal minus 4 square root of x. I divide both sides by minus 4, and I get 4 equals square root of x. And I'm going to rewrite it like this. Well, I still need to get rid of the radical sign. So there's part 2. I square both sides and I get x equal 16. Now I need to check it to make sure I don't have an extraneous solution. So I take the square root of 16 minus 12. Does it equal to 2 minus the square root of 16? So the square root of 16 is 4. 2 minus 4 is negative 2. Let's see, I'm doing some bad math here. Oopsie. Oh, no, I didn't do bad math. Okay, and then 16 minus 12 is 4. That's 2. Does 2 equal negative 2? No, it doesn't. So guess what? This is an extraneous solution. So on the test, you cannot give me x equals 16. All right? That's all there is to that. Now let's look at inequalities. Just like quadratics, we had inequalities with 2 variables and 1 variable. A couple sections ago, we did 2 variables, which we just graphed the transformation of the square root, and we shaded. Well, now we have 1 variable. So, for instance, example 3 says solve 3 plus the square root of 5x minus 10 is less than or equal to 8. Well, I only have 1 variable because remember it's less than or equal to some number instead of y or f of x. So therefore, I have to do what we did with quadratics. So the first thing you do is you need to identify the values of the variable, which means we solve. So we do the square root of 5x minus 10 less than or equal to 5. Right, a minus 3 from both sides. I square both sides. And I get 5x minus 10 equal 25. I solve for x. 5x equal 35. This is a 10. X equal 7. Okay. Whoopsie. X less than or equal to 7. Oops, we gotta keep our inequality sign. All right, however, I need to check points. So I'm gonna go to 7, right? So we're saying x is less than or equal to 7. So the next thing I have to do is I have to check points to see if it's true. So you see up here, we also, because we have a radical, is one thing we have to remember is we have restrictions on the domain, right? This can't be negative. So I need to find 5x minus 10 when it's greater than or equal to 0, greater than or equal to 10, x is greater than or equal to 2. So I have this solution, right? Greater than or equal to 2 and less than or equal to 7. So I start with those points, and I'm going to test a point to the left, a point to the right, and a point in between, and a point to the right. So here, 0 is obvious. Here I'm going to test 3. Let's see what they did. They tested 4. Okay, so they test 4, and they tested 9. All right, so if we look at the chart, I'm not going to do it. We put 0 in, we get not a real number because we have a negative under the radical sign. So there's not a solution there, right, to the left of 2. Then we put 4 in between here, and we get 6.16 is less than or equal to 8. That's a true statement. That works. Now we pick a point 9, and we get 8.92 is less than or equal to 8. That's a false statement, so that does not work. So this was false, false. This was true, therefore my solution is going to be from here to here, and I would say x is less than, or 2 is less than or equal to x less than or equal to 7. So you just test both points. All right? That's all you do. You have to find the solution, find any restriction. So remember, we take the radicand and make it greater than or equal to 0 to find the domain. And then we test points in between and to the left and right of those solutions. Now, I did skip a section here. Let's go back to example 3. Now, what undoes, if I take the square root of something, I can undo it by squaring it. Likewise, if I take the cube root of a number, I can undo that by cubing it. All right. So we're going to look at radicals. We talked about earlier how to change when you have an exponent as a fraction, then we're going to have a radical sign. So let's solve this one here. All right. This is example number 2. All right, so the problem gives you 6x minus 3 raised to the 1/3 minus 4 equals 0. They did not give us a radical sign. Instead, they said this whole thing in here is raised to the 1/3. So that's like a radical sign. I have to isolate it. So I'm going to plus 4 to each side, and I'm not going to spend a lot of time with the algebra here. And then I'm going to divide by 2. Okay, how do I get rid of this 1/3? That's the same thing if I said the cube root of some number in here. So I cube it. So I'm going to raise this to the 3rd power. So I have to raise this to the 3rd power. By definition, a power raised to a power, you multiply 1/3 times 3 equals 1. So then we get 6x minus 3 equals 8. Now we just solve. Equals 11. And x equal 11 over 6. So we do it the same way, except for instead of having a radical sign, we use a rational number as our exponent. All right. And again, we check it to make sure that that value works. All right. Let's move on to one more little section. So here, how do we solve this? Remember, this is to the 4th power. Same thing. So we would plus 6, divide by 3, raise both sides to the 4th power, and solve it. Okay? That's it. So it's just equations and inequalities. Do your problems, and we'll see you in class.